Our next topic is ampacity. All right, ampacity is the maximum current carrying capacity of a wire and its consequent heat dissipation ability. All right. The important thing to realize about ampacity, or all of this stuff, and I've said this 100 times, right? Probably more. Everything in the code book is about heat. Heat is what's bad for electricians. If we don't put in the proper size wire for the proper size application, we risk overheating wires and then damaging people's homes, damaging people's lives for that matter. So this is why it's important to understand this stuff. This is why you sit in class. This is why you're watching this video. The big thing here now is table 310.15b16 lists the ampacity rating of each standard wire size. So that's a nice thing they gave us, which is actually right here. Okay, this again is out of the code book, but you'll be able to use this for doing your calculations. All right, it says you can select a wire size from this table if the wire will be installed in the following conditions. All right, so in order to use this chart, we have to meet these conditions, which are not more than 3 current carrying conductors in a raceway or cable, maximum ambient temperature of 86 degrees Fahrenheit, and the conductors with rating of 0 through 2000 volts. Okay, so if we are going to use this chart, we have to meet all of these things. Okay, so far so good. All right, now we'll go to the next part. It says selecting conductor size. All right, a utility room in a home that you are wiring needs a 20 amp receptacle. All right, for the washer and dryer. But the important thing here is we want a 20 amp receptacle. Conduit will be run from the circuit breaker panel to the box in the utility room, big here, without going through the attic. The conduit will be the equipment ground. That's not, yeah. Don't worry so much about that. The conduit will be equipment ground and contain 1 current carrying conductor and 1 ungrounded conductor. All right, so remember the current carrying conductor is our ungrounded, right? It's our hot, and the 1 grounded conductor is our neutral. All the conductors will be THHN, okay, copper, because the situation meets the 3 criteria listed. Well, does it? Okay, let's go back and look at this. It says it's not going through an attic, okay? So the one thing is we can be pretty sure that we're going to meet that 86 degrees, okay, because we're not going through the attic. People tend to keep their house pretty decent. All right. Then from there, it says contain 1 current carrying conductor and 1 hot conductor. So no more than 3. Well, in this case, they're using the conduit as the ground, so they're only going to have the 2 conductors in it. So that means that we are not more than 3 current carrying conductors. So that's a good thing, right? And then the last thing, we're using THHN. So yeah. So now is where they start to mess with us, and this is where people get a little bit confused. If we look on that chart quickly with all that stuff we just said, all right, we're in the THHN. So this chart, which by the way, let's review 310.15b16, formerly, yeah, whatever. Allowable ampacities of insulated conductors rated up to and including 2000 volts. 60 degrees through 90 degrees, all right, that's going to be important, or 140 through 194, all right, Celsius and Fahrenheit. Not more than 3 current carrying conductors on a raceway, comma, cable, comma, or earth directly buried, based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. So right here on this top, it clearly states everything that was said here, all right. This was easy to read. This time, sometimes we look at it and be like, oh, it's little writing and I don't want to do it. But it's important when we read this stuff that we look at these things, especially in the code book. Okay? Back to our problem. So it wants a 20 amp receptacle. All right? So if I want 20 amps, all right, THHN, okay, so here's my insulation. It's in the 90 degree column. THHN, okay, and we're looking for 20. So the next one I have is 25. So 25, if I come over, is rated for 14. Okay? I hope you guys can see that. 14 now. Notice those 2 double asterisks. The book is going to talk about them. It's going to say, it appears that 14 American wire gauge is ample, right? 25 compared to the 20. but there is an asterisk next to it. The table of 14, next to the 14 in the table. This asterisk directs you to section 240.4D, which if we had our code books, we would go to that, but we can't, so we won't, where it is stated that a 14 American wire gauge conductor can be used in a circuit rated for a maximum of 15 amps. Well, that's no good for us because we want a 20 amp circuit, 14 wire. Though the book says it's 25, the two asterisks say, nope, go to this section and where it tells us that we're maxed out at 15. Thus, a 12 American wire gauge conductor is needed in this utility room. Okay, so now if we go 14, remember we had our 14, all right, is 25. So the next one, this 12 we talked about, which also has two asterisks, notice that, is good to the 30. So we should be good with that. Not trying to confuse you guys, but if we talk about the section 240.4D, if you remember I said that they put a lot of the charts in the book or the tables in the book. Well, we're lucky enough that down here we notice that this is conductors in 18 wire gauge to 10 wire gauge have maximum ampacities designated in section 240.4D. And here they are. And it states that an 18 American wire gauge can have no more than 7 amps. 16 can have no more than 10. 14 can have no more than 15. 12 can have no more than 20. 10 can have no more than 30. And then aluminum or copper clad aluminum is 12, can have 15, and 10 can have 25. This, you know what I mean? It's important that you know that, but like I said, I don't think you're ever really going to use it that often. The big things that I want to make sure you understand, this 14 is going to be hugely common in your residential wiring work. This 12 will be hugely common in your residential wiring work as well as your commercial work. And then the 10 is, you know, you can find it everywhere. Those are the big three. Size number 14, the stuff we use in our shop every day, has to be on 15 amps, or no more than 15 amps. 12, no more than 20. 10, no more than 30. Let's go back. If you wanted, so we just said 10, no more than 30. Well, 10 is actually good to 40 amps, all right? So 10, THHN is good to 40. 12 is good to 30, and 14 is good to 25. That's what the chart says, but in reality, that those asterisks supersede it to this chart, which you would find in the code book at 240.4D. Okay? So, with that, I hope we got things rolling here. Now we're going to do multiple conductor ampacity adjustment factors. Okay? Bear with me. Alright? We're probably going to do more work on this little camera than with you, but I'll keep you running in case. Okay? It says the three conditions in table 310, 15, B16 are required because the ampacity rating of a conductor will decrease as the temperature of the conductor increases. Alright? That's everything. Okay? You need to understand that principle. That the three conductors in table 3, or the three conditions in table 310, 15, B16 are required because the ampacity rating of a conductor will decrease as the temperature of the conductor increases. Again, the ampacity rating of a conductor will decrease as the temperature increases. All right, remember, heat is bad. All right, well, I mean, heat is what it is. We need to learn to work with heat. Okay. Having multiple current carrying conductors in one raceway or cable increases the temperature of those conductors. Does that make sense? So if I know that I'm creating heat on these conductors and then I take a bunch of them and put them in one conductor or in one conduit, right? I'm going to be raising the heat level of all of those conductors. So I need to account for that. All right. So with that, we have to have an adjustment factor. Okay. An adjustment factor is a percentage that is used to reduce the ampacity of a conductor based on the number of current carrying conductors in the raceway or cable. So, again, the book has helped us out, right? So far, we haven't had to look far. So far, we've had this piece of paper, which I will put in a PDF that you can find on Google Classroom. You have this one, which states what size or how many amps we can put on a conductor. And then now we're up to this one, which is the ampacity reduction of more than 3 current carrying conductors. So if I have more than 3, this is what I'm forced to reduce it to. So if I have 4 to 6, I'm only allowed to use 80% of the amperage value. 7 to 9 will be 70% of the amperage value. 10 to 20, I have 50%. 21 to 30, so on and so forth. All right, I think you guys can figure that out. All right. When more than 3 current carrying conductors will be placed in a raceway or cable, refer to Table 310.15b3a. Boom. Which is this. Doesn't look quite like this in the code book, but it's still valuable. So the book goes on here now. It says, for example, a run of conduit to a kitchen will contain 7 THHN current carrying conductors, 1 for a 50 amp oven and 6 for various 20 amp appliances and receptacles. According to Table 310.15b16, the 50 amp conductor should be 8 American wire gauge and the 20 amp conductor should be 12 American wire gauge. So let's go look at that. It's saying that a number 8, I want to keep this straight, number 8 will be good to 55 amps. So that should be good, right? Well, let's start figuring this out. Okay. If I have a number, all right, and so this is going to be adjustment factor. And it's important that you remember that adjustment factor is the number of conductors within the conduit. All right, so we're doing the adjustment factor. I apologize for my terrible handwriting. Okay, we are looking for 50 amps. All right, it goes on. Yep, so we're looking for 50 amps, and there are 7 current carrying conductors. The first thing we're going to do now is go to this page. This page shows us that our American wire gauge number 8 is good to 55 amps, as I just read to you. So I have number 8, and I'm going to write THHN. Okay, so I have number 8, THHN, and we need, is good to 55 amps. So number 8, THHN, good to 55 amps in the perfect scenario. From there, we are going to times that by the 0.7, because we're only allowed to use 70% of that 55 because there are 7 current carrying conductors. 55 times 0.7 equals 38.5. Okay, that is not enough. All right, so because we derated this wire from 55 to 38.5, it's not enough. So all we can do now is go to the next size wire up. So if we go back to the chart here, we were just at 55 and 8. So now we'll jump to a number 6, which is good to 75. I will now say number 6, THHN, and that is good to 75 amps times 0.7 equals. What do you think we got? So I got 75 times 0.7 equals 52.5. Okay, so now we're good because I have I need 50 amps, I need 52.5. So we took this number 6 and derated it from being able to carry 75 in the perfect scenario that the chart describes to now, because we have 7 current carrying conductors, this number 6 is good to 52.5. So number 6 is the size wire we would have to run. Okay, so continuing on with this adjustment factor part, let's do an example problem before we move into our correction factors. Okay, all right, so for this one, I want to take a 60 amp THWN conduit with 8 conductors. So the big difference between the problem previous and the problem here is that we need this THWN. This was THHN. Remember, the THWN and the THHN refer to the insulation types, which can be found in the top here. Okay, so we just went from THHN, which is in this 90 degree category, to now we're going to be going to THWN, which is in the 75 degree category. The one thing I need you to be aware of is THWN is THWN. Over here, THWN2 is THWN2. Don't confuse the two, okay? Right now we're messing with THWN. Okay, so with that, I'm still looking for the 60 amps. So I'm going to be in this chart here now because that's where I find THHN. And 60 amps, so we have 65 is number 6 wire. Okay, number 6, sorry, THWN is good to 65 amps. I said 8 current carrying conductors, right? So if I take the book and I go over here, still within that 7 to 9, I'm still at 70%. So I have to take the number 6. Sorry that I screwed that up there. Number 6, THWN, 65 amps, times 0.7 will equal 65 times 0.7 equals 45.5. Okay, so that is again too small. So we just said number 6. All right, so now number 4 is good to 85. So I'm going to say number 4, WN is good to 85 amps times 0.7 equals. So I'm looking for 85 times 0.7 equals 59.5. Oh, that's no good. Alright, well, and these are amps. So I have 60 amps, 59.5. It's not good enough, right? So now I gotta go back. The next size up is a number, so we did 85. Number 3 is good to 100 amps. So now I'm gonna write a number 3. THWN, good to 100 amps times 0.7 equals, all right, I think we should probably be able to almost guess what this should be, but if I do 100 times 0.7 equals 70%, or 70 amps, I'm sorry. So that's 70 amps. That is now good enough. So again, these are 2 examples, 1 and 2, of adjustment factors. Okay, we were looking for 60 amps under the chart. If we only had 3 current carrying conductors, number 6 THWN 65 amps would have been good enough. But because we had 8 conductors, we had to put in this adjustment factor. So we derated that wire from being to 45.5. We kept derating each wire. We took number 4, which would be good to 85, derated it to 59.5, and we took the number 3, THWN, 100 amps, times 0.7, which is now 70 amps. So this number 3 wire is what we need when we have 8 current carrying conductors and a conduit to carry the 60 amp. Okay, so far so good. Before we move on to correction factor, it's really not that hard. I strongly recommend that you follow the process until you get the hang of it. Okay.